Hi, welcome to the Calculus 3 and assignment worksheet series. And we are in the unit partial derivative. This is our assignment number 5, and we're going to work on the chain rule. Okay, so let me go to our assignment worksheets here, and then we'll try to work on some problems here. Okay, so for this unit here, we'll talk about the chain rule for the partial derivative. So the first pages here, those are just a very, very mechanical, like the problems here, and you can just apply the chain rule formula to do it. So the first problem I'm going to do is the problem number 16. Okay, so I'm going to work on the problem number 16 here. Okay, so the number 16, let's say, suppose f is a differentiable function of x and y, and the GRS is f function of 2r minus s and s squared minus 4r. Use the table of the value in the previous number 15 here, calculate the GR and GS is here. So because we know the function g is a function of r and s, and the function f here, so that means I know the x here is equal to what is 2r minus s, right? And the y here is what is s squared minus 4r here, okay? So in order to find, the GR, okay, so the GR, the RS, that means I'm taking what? I'm taking the partial derivative of r here, right? So both x and y is equal to r. So the first things here, we're going to be what we said is rho f, rho x, and then the rho x, rho r, plus rho f, rho y, and rho y, rho r, right? Because they both have two variables. Okay, so now let's take a look at rho f, rho x here, right? So that means this will be what? It will be the partial derivative of x here. Okay, so that will be the partial derivative of x. And then the rho x, rho r is 2, it's correct? Right, because the x is 2r plus minus s. Then the rho f, rho y here, rho f, rho y here will be the partial derivative for y, for the f of x. And then what is the rho y, rho r is -4 here. Okay, so now we need to figure what type of the values I'm going to put in here. So we're looking for is GR1, 2. Right, so GR1, 2, that means the R is equal to 1 and the S equal to what? Is equal to 2. So it's R equal to 1, X equal to 2. What is the X here? Is 2 times 1 minus 2 is 0. What is Y is here? Y is 4 squared minus 4. Is 0 here. So what is we're looking for here? So we say it's the partial derivative of 0, 0 times 2. Plus the partial for y, 0, 0 times -4, right? Okay, now I look in the tables here. The partial f of x, 0, 0 is 4, so it's 4 times 2. Then partial for y is what is 8 times -4. So what do we have here? So we end up to be a -24 here. Okay, so let's try to do one more for the GSSR. So it's the same things, right? So it's rho f, rho x, now it's rho s, right? Now you have rho f, rho y, and then now you have rho y, rho s here. So it's the same thing here. This is the partial for x. Then what is rho x, rho s here is -1. Then plus this is the partial for y. So what is the rho y, rho s here? Is what? Is 2s, right? Okay. Now we know we want to find the GS1, 2. That means it's f of x 0, 0, negative 1 plus f of the y 0, 0, 2s. Okay, so the f of 0, again, so it's 4 times what? 4 times negative 1, then plus 5 times, what is the 4s here? What is the 2s here? 2s is 4, right? So it's the 4 times 8. So what is here? This is 28 here. All right. So I guess, so for this problem, the key here is you need to know, that if x is this one, y is this one, and for a given r and s, right? Then you need to figure out what is x, y. That's basically this problem try to test you. Okay. So now let's try to find another problems here. So another problem I like to do is let's try to use the differential equations and try to do it and to kind of refresh our memories here. So I want to find the rho z, rho x, and the rho z, rho y, right? So this is a differential equation, implicitly differential equations problems here. So let's say, like we said, we'll put x, y, z, right? So it's moved everything over. So this is yz plus x natural log y minus what? Minus z squared equal to 0, right? Then we say, first things here, okay, so we do a partial for x, right? So the partial for x, so first term is 0. So what is here? This is a natural log y. That's it, right? Then we have a partial for y. What is the partial for y here? Will be z, and the natural log y is what? 1 over y to the x. All right. Now, partial for z's here. Partial for z's will be y minus 2z. Right? Okay, so now remember that's what we say here, so we said that if you want to find the rho z, rho x, so it will be what? It's negative f of x, f of z, right? So what is this one will give you? So the f of x is natural log y, so it's a negative natural log y. What is z? fz 1 minus 2z, right? So it's pretty easy by using this method to use a partial derivative to find the implicit differentiations, right? Okay, now this is rho z, rho y. So it's the same thing, you put the f of y here, right? And the f of z. So the negative f of z is just 1 minus 2z. What is the f of y? Is z plus x over y, right? So that's it. So it's pretty easy by using the partial differential equation to do that. Okay, so after that, I'm going to work on word problems here. So this is the number 35. They said the temperature at the point is set at Tx1, measure the degree in Celsius. A bug across, so the position after the t second is x is square root of 1 minus t, y is 2 plus 1/3 t, where x, y are measured in the centimeter. So the temperature satisfies, so the partial derivative of x to 3 is 4, and the rate of temperature change to 3 is 3. So how fast is the temperature rising on the bug's path after 3 seconds here, right? So we want to see how fast the temperature rises. That means I'm looking for what? I'm looking for the temperature change over, let's say, after 3 seconds. So you need to know how to set up the problems, right? Because that's the rate of the change for temperature. So you say the change of the T over the times, right? Okay, so for 3 seconds, right? So we said 3 seconds. So let's take a look. Where is the position? X is equal to, so this is my T's, right? So it's 1 plus 3. So X equal to 2. Then Y is equal to 2 plus 1 over 3 times 3. It's 3. So that means here they already give us this information at the position 2 and 3 here, right? So now I'm looking for the temperature change over time. So that's why we say we know the temperature change going to based on the position. But the position x here is a function of the t, then plus the temperature change over the y position, and the y position change depends on the t's here, right? Okay, so now what is rho t, rho x here? That means, what is that? That means it's your partial derivative of tx, right? Then at what? At the 2, 3. So what is the dx dt here? Dx dt, x equals the square root. So the dx dt is 2 over 1 plus t to the 1. Then plus rho t, rho y. That means I know this is a partial derivative for the y's here. So it's 1, 3, 2, 3. So what is the dy dt here? It's 1/3, right? So now in here, for these numbers here, we say at t is equal to 3 seconds here, you place by 3. Okay, so now what is the final answer here? So tx partial derivative at tx 2, 3 is 4 times, this is 2, so it's 1 plus 3, so it's times 2, right? Square roots here. Then plus ty 2, 3 is 3, right? Because in here, then times 1/3. So what is here is 2. So how do you interpret it? Is 2 here? So we say it's a temperature, right? So we say temperature rise at temperature rises at 2 Celsius degree per what? Per seconds here, right? So this is the other application problems here about the partial derivatives, right? Okay, so now let's take a look at the next one. Let's like to do another ones here. Okay, so let's take a look at the number 38. So we say the radius of the right circular cone is increased at the rate of 1.8 inches per second, while its height is decreasing at a rate of 2.5 inches per second. And what rate is the volume of the cone change when the radius is 120 and the height is 140? Okay, so let's take a look. So this is our, we call it is the right cones, right? So when the height decreasing and then your radius. So here is the radius, right? So the radius is going to be what? Going to be increasing here. Okay, so now let's write down all the information we know, right? So in here we say the radius is increasing at the rate, all right? So what is that? So what is this information give us? That means this is dr dt is equal to what? 1.8, right? Then they tell us the height is decreasing at a rate of 2.5. So what is that information tell us? That means d height dt is equal to what? It's negative 2.5, right? Because it's decreasing. And we want to know what is the rate of the volume change when the radius is 120. That means when the radius is 120 and the height is 140. So what do we want to find here? We want to find the volume changes, right? So we want to find what is the volume changes, right? Okay, so let's write it out. So we know the first thing is volume is equal to what? For the cone is pi r squared times h divided by 3, right? So I want to find the volume change over times, right? So that's why we say so we said the dv dt, right? So the volume change over time. So we know the volume change over r, right? So we said rho v rho r. Then we have a dr dt. Then plus the volume going to change is rho v, rho h. Then we have a dh dt here, right? So now let's take a look here. Rho v, rho r, this will be 3 over 2 pi r h, right? 2 pi r h dr dt. What is dr dt? 1.8. Then plus rho v, rho h. So it's a pi r square over 3. H derivative is 1. What is dh dt? Is negative 2.5. Now I can plug in the numbers. So this is 3. This is 2 pi. R is what? It's 120. H is 140 times 1.8 plus pi. What is R? 120 square. And this is 3. And what here? This is a negative 2.5, right? So I will have here, so this is A160, okay, pi inches cubed per second. That means here, this is the rate of my volume going to, this is the rate of my volume going to change at this rate here, okay? And so, okay, let's take a look at the other. Okay, so the next one, I'm going to I'm going to take a look at another work problems here. So this one's here. So I just want you guys familiar with those word problems because that's the main things for these sections, right? The mechanical part is quite easy. So the voltage V is in a simple electrical circuit is slowly decreasing as the battery wears out. The resistance R is slowly increasing as the resistor heats up. Use Ohm's law, V equal to the IR. Find out how the current is changes, right? Okay, so now I want to find how the current is changed. At the moment, R is equal to 400 ohm, I is equal to 0.08 amps, and the dV dt equal to negative 0.01 V dr dt. Okay, so I'm looking for the R, so I need to change the Ohm's law to the R's, right? So R is equal to what? V over what? V over R's, right? So now here this is, okay, so it's D current, right? Current over time, so dV dt. So we do the same thing. So we say rho V, rho, okay, so I'm sorry, it's here. So this one will be the, what is rho I, rho V's, right? And then times the dV dt plus rho I, rho R times dr dt's, right? Okay, so the current take the derivative of the V. So what is here is 1 over R, right? So it's 1 over R. dV dt is what? Is negative 0.01. Okay, rho R, rho I, rho R, rho I, rho R is what? So this is, so this will be the negative V to the R square, right? Okay, so then the dr dt, this will be the 0.0 what? 0.03. So take a look at these ones here. Okay, so the V over R here, right? So V is equal to V over R square. So V equal to the resistance times R to the R square. So you cancel one, so it's IR. So this is the I, right? So this is the current over resistance. Now I can plug in the numbers here. So this one will be equal to 1 over, when the R is 400 times the negative 0.01, right? And then minus current is 0.08 over R is 400 right? So then d what? dr dt, this is a 0.03, right? And then if you plug into the calculator, you will get this is a negative 0.1234. So 1, 2, 3, 4, 3, 1 amp per second. Okay, so like as you can see, this is kind of like similar to the related, related rate, right? Because they're both related to a variable times, and then you try to kind of use the partial derivative to find the rate of the change. See here. Okay, so let's do one last one. See here. This one see here is interesting proof problems here. So okay, so we set a function, we call it the homogeneous of degrees n, if it satisfies these equations for t, and n is a positive integers here. So like the first one is say, hey, try to verify that this one is a homogeneous with degrees of 3 here, all right? So this is just like the first one is nothing, not really have anything to do with the derivative. It's just say, okay, so I have f of what? Tx and f of ty. That means all my x in my function, I'm going to replace with here, right? And all my y in my function, I'm going to replace with this number. So this one's here will be the tx squared ty, then plus 2 the tx ty squared plus 5. This is a ty cube. Okay, now take a look here. So the t and the t squared. So this is a t cube x squared y plus 2 t, right? So t what? So this will be the t cube xy squared and plus 5 t cube y cubed, right? Okay, now factor the t cube out. So what do you have here? This is x squared y plus 2xy squared plus y cubed. Oh, this one is equal to what? F of xy. So that's why this one is equal to the t cube f of xy. So that's why we know the f function is homogeneous with what degrees here? Degrees 3 here. Okay, so now let's take a look. We said if this is a homogeneous, right, with degrees of n's here, let's see here. Okay, so let's show this partial derivative is truth here, right? Okay, so because homogeneous is the degrees of n, so based on my definition, so I know that f of tx, ty equal to what? T to the nth power f of xy, correct? All right, okay, so now I'm going to, so if I take the derivative of the rho t here, the f of tx, ty, right? So it will be similar, you take the rho t to the t to the nth power f of xy, right? You take the derivative of t both sides. Okay, so in here, okay, because this function is tx, so when I take so this is a very good problem for the concept of partial derivative, right? But I need to take the derivative for the t, the partial derivative for the t's here, right? So basically, so this one's here, it will be what? So this one's will be, so this one's here, right? So this will be the, you really is take the rho the tx, so f of the tx ty, and then what? You need to do what? You need to do the chain rules, right? So that means what is here? This is the rho the what? Rho the tx. You need to take a derivative to the rho t, right? So the same way is here. you have rho, the rho ty. So you have f of the tx ty. Then the chain rule, you have rho ty. Take a look at the rho t. Okay, so now let's take a look here, right? Okay, so what do you have here? This one, right? So rho tx, you take a rho t. What is this one going to give you? This one will give you x. And what is this one going to give you? This one give you what? It's y's here, right? So I know this one's here, right? So I know this one's here. I know the rho, the tx, f of the tx ty times x plus rho, the ty, f of the tx ty times 1. So if you set t equal to 1, take a look at what you have here. If you set t equal to 1, okay, so if you set t equal to 1 here, right, okay, then let's take a look at what you have here. Okay, so if t equal to 1, so this is really is rho the what? Rho x, f of what? xy, the x's, right? Then plus, because t is equal to 1, right? So this is rho y, then this is x and y to the y. Oh, wow, what is this? Right, so what is this here? That is just the rho f rho x times x, and what is here? This is just rho f rho y times what? Times y. Okay, so you add it. Okay, so then you take the derivative, right? For these terms here, your rho t is here. So, okay, so my right hand side, I'm taking the derivative. So what is here is n t to n minus 1 f of xy. Because t, we set t equal to 1. So what is here? So it's n of the f of xy. Okay, so this is a pretty cool, so, right? So that's how do we prove this one here by using the partial derivative properties here. Okay, that's it. And like I said, this section is kind of a very mechanical section, but the application part is very similar, like in the calculus 1, when we learn the related rate, right? So you have some variable related to other variables, and then both of them related to the, like the third variables, like times here, right? And then you want to find what is the, what is the rate of the change for your, for example, for your volume related to the radius and the height, right? So it's kind of like a similar, like related rate problem, and we just use the partial derivative concept to solve it. Okay, that's it. And I hope the few problems we did here can help you to understand how to apply the chain rule in the different area. Okay, that's it. You have a nice day, and I'm looking forward to talk to you in our next unit here. Okay, bye.